So in the last journal, if you look at journal 29 continue, we talked about this formula. So I decided to bring it up as a bell work so we can practice those skills. But it's using the formula SAS, which stands for side, angle, side. And this formula helps you calculate the area. So anytime you're given like a non-right triangle, it's really nice to use this formula if you have two sides of the triangle, which we do here, two sides, and we have the angle that's between them. So let me just draw you a picture here and how you can relate this back to the SAS formula. So if I were to draw just a triangle to represent this picture here, let's pretend this is A, so this would be 56.80, and then this would be little a, and then let's call this B and this C. But in this case, we don't have, big B or big C, but we do have little b, which is 32.67, and we do have little c, which is 52.89. So I want you to take a notice that you have the side, angle, and then a side. So you have side, angle, side, which tells me you can use this formula here. And the formula to calculate the area is 1/2 times the two sides, B, C, times sine of the angle. So that's the formula if you need it. And so if I were to follow this formula, it's a fairly easy formula to follow. All you got to do is plug in your side, so your B and your C. So I'm going to plug in my B and my C into the formula. So B is 32.67 inches times 52.89 inches times sine of A, which is 56.80 degrees. And if I type this in the calculator, I can just type it in one go too. By the way, a nice way to type in 1/2 is just to do 0.5, right? You can always write this as 0.5. It just makes it easier to write in the calculator. So what's 0.5 times 32.67 times 52.89 times sine 56.8? So I got this number, 722.9. And because, this is area and it's in inches, it's going to be inches squared. And so here is my final answer. And so when you're using, when you're given two sides and an angle, check to see if it's an angle side, a side angle side triangle, to see if you can use this formula here, because it's really nice if you're just calculating the area. So today I want to talk to you about situations where you have like an oblique triangle and you need to find, either the sides or maybe an angle, but maybe you're given all the sides. So there are times where you might be given all the sides and no angle. So let's pretend, I don't know, this is A, this is C, this is B. If that's the case, that means that the angle, this one would be my A, this one would be my B, and this one would be big C. So let's pretend for a moment if you were given all the sides. So in this case, if you're given all the sides, you might want to use the law of cosine because it takes in the sides. You'll notice that, and then you can solve for the angle. So this formula works great if you have side, 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 all the sides. This formula also works great when you have maybe a side, angle, side. Basically, this formula works great when you have a lot of sides, maybe one angle, or if you have all the sides. This doesn't work well when you're given a lot of angles. If you're in that scenario, I highly recommend the laws of sines because that'll take care of it. Now, I want us to look at the formula here. So I put in two formulas, but there's actually a third one, and you will notice they're very similar. So just take a look at the pattern. If you have the side A and you square it, it's equal to B squared plus C squared, the sides, minus 2 times BC times cosine A. First off, notice how when this is an A, the angle's an A. When the side is a B, the angle's a B. So also, if this was, C squared, then this would have to be cosine of C. I'm just predicting here. You will also notice if this is an A, then the sides that are inside are always going to be the sides that it's missing. So if this is A, then B and C are not A. And then it's B and C again. So if you notice if this is B, then you're using A and C, which is the other two. So if I'm getting C, then this is going to be an A and a B. So an A squared plus B squared minus 2AB is my third formula. And that's how I can extract that formula from looking at the ones that are given. So here's the thing. I never memorize laws of cosine. I just have to memorize, like, at least not all of them. But I do memorize one of them, and then I can figure the other piece out. Because the trend is very similar. When you choose a side that angles corresponds, the other sides that you're going to be using are the ones that are not associated to A. So the different ones on the triangle. So we're going to be practicing using law of cosine to solve out a triangle in the next slide. All right, so this is some problems you can find in chapter 20.3, and these are problems from 9 to 32. So first off, it's asking to find the length of the remaining side of the triangle. So in this case, you are given two sides of the triangle and you're missing one side. I'll call this side, I'll just call this side angle A. Sorry, not angle A, side A. And so I'm missing side A. So I'm going to pretend that this angle here is associated to this side since it's diagonal. And so I'll call this angle A. And so this gets to be angle B, angle C. So this is going to be little c, this is going to be little b. And so from here, I'm just trying to find this side. So let's take a look at what I already know. So in this case here, I already know two sides and an angle. So this is side, angle, side. Well, if this is side, angle, side, this works great for a cosine, law of cosine. So law of cosine states that if you're looking for a squared, then you need your two sides, which would be b squared plus c squared minus 2bc times cosine of a, which is, in this case, 60 degrees. So I'm going to plug in everything that I know in this formula. So I have an a squared, don't know what that is. B squared is 8 squared. C squared is 3 squared minus 2b, which is 8 and 3. And then from there, I need to multiply this by cosine of 60 degrees, because that's my angle. So what I'm going to do is bring the a squared down, and then I have to work this part out. So we're going to figure out what's 84 times 8 squared plus 3 squared minus 2 times 8 times 3 times cosine of 60, and see what you get. So it turns out I actually get 49, strangely. And so if I take the square root of this to get rid of the square, I get an a that drops down. The square root of 49 is 7. Don't worry about the negatives. When you take a square root, it's going to be a positive 7. So in this case, a is equal to positive 7. So this length side is 7. All right, let's try another one. So in this problem, they actually want you to find the angle, and it's the angle between 3 and 5. So I recommend probably, like, declaring what your side is called. Like, is this one A, B, C? So in this case, I'm going to call this angle A, this is angle B, and this is angle C. And so we have little b, little c, and little a. And so in my case, I just need to figure out what this theta is, or what angle B is. So if I want to know what angle B is, that means if I backtrack, I need to figure out what little b is. And so I have a squared plus b squared, sorry, not b squared, c squared, since a and c are not a part of b. So you have a squared plus b squared equal minus 2AC. And so from here, I'm just going to plug in what I know. I know what my B is. I know what A and C are. I just don't know what cosine of B is. So I have to solve for that out. So B squared is going to be my 7 squared minus A squared, which is 5 squared, plus C squared, which is 3 squared, minus 2AC, which is 5 times 3, cosine of B, which is just the angle. So in this case, I'm solving for B. So I'm going to multiply these out for a moment. So 7 squared is 49. 5 squared gives me 25, plus 3 squared, which is 9. If I multiply this out, 2 times 5 times 3 gives me 30. And then I have a cosine of B. So if I were to add these two up, this would give me 34. So how about I reduce this and make this look nicer? So 25 plus 9 gives me 34 minus 30 cosine of B. So if I subtract 34 to both sides, that cancels. And so then this becomes 15. And then this becomes negative 30 cosine of B. So when I'm solving this out, oops, sorry, I meant to write B. So from here, I'm going to try to divide by negative 30 to get rid of this negative 30 on cosine. And so this gives me cosine B. 15 divided by 30, if you reduce it, is negative 1/2. So if I find what is the inverse cosine of 1/2, then I'll get my answer. So this will cancel. And so B here is cosine to the negative 1, so the inverse of cosine, negative 1/2, which is equivalent to 120 degrees. And that's it. All right, so let's do one more triangle where we're solving everything out, and then we'll call it a day. All right, last but not least, so this last triangle, I'm given an angle and 2 sides. So it's very likely that I'm going to need the law of cosine given the items that I have. So A, again, is 41.4 degrees. I'll call this angle B and this angle C. And so in this case, little b is 2.78 yards. And then little c, which is up here, is 3.92 yards. And so in this case, what I have to figure out is what is this side, little a, what is this angle b, and what is this angle c. And so to do that, if I'm trying to find all this stuff, I need to know what big B is, small a, and, oh, I guess I need to figure out my angle as well. So angle B, angle C, and letter A. So side length A, and I think that's it. So let's get started. So to use this formula, I have to use the law of cosine. So I'm just going to write it up here for the when you have A. So in this case, I'm going to plug in what I know. I don't know what A is, but I know what B is and C, and I can plug in the rest from here. So just using this formula, you have B squared, which is 2.78 yards. C here is 3.92 yards squared. And then minus 2 times B, which is 2.78. And then multiply that by the other variable, which is 3.92. And this will be sine of A, which is 41.40. And so I'm going to just type this all in the calculator and see what I get. And so it looks like here I got, so when I put this in the calculator, I got 8.68. And if I take the square root of that to get rid of the square, I would have A is equal to 8.68, which is 2.95. And considering the other lengths here, this is a pretty reasonable length, especially since that one's 2.76 or 78. So this is one of the answers that I'll write down. 2.95 yards. Let's make sure we put it in the units. And then in this case, you also need to tell me about A. So A is this side here, and it's a length. And so what I can do here is figure out, what's the length based off like what I'm given. So because I already know all the side lengths, what I can do is plug in all the sides, so A, B, and C, and calculate an angle. So I could really use angle B, so I'm going to start with angle B. So what I'm saying is that I can use the law of cosine, specifically when you have cosine of B. So this would be B squared equals A squared plus C squared minus 2AC cosine B. So if you were following this formula here, I'm going to plug in what I know, which is that, B squared is 2.78 equals A squared, which is 2.95, and C squared, which is 3.92, minus 2 times 2.95 and 3.92, and then cosine times B. So I seem to have ran out of room, so what I'm going to do here is I'm going to shrink this, there we go, and then I'll erase this part and I'll scoot this over. So all I've done is written this out, and then I'll try to simplify and clean this up. So 2.78 squared, that is actually 7.7284. If I were to square 2.95 and 3.92 and then add them together, I would get 24.0689. And then if I multiply these together, 2 times 2.95 times 3.92, that would give me 23.12 cosine B. So now from here, I'm going to subtract off 24.0689 to both sides. So 7.7284 minus negative 24.0689. That's going to give me negative 16.340. And then I have to divide by 23.12. And so that gives me cosine of B, which is equal to 0.707. And so from there, I have to take the cosine inverse. So that cancels. And so what I have left is B is equal to cosine inverse of 0.707 is going to be 45 degrees. And that's my answer for the angle. So it's like I figured out the angle, which is, so angle C I do know now is 45 degrees, which is kind of nice. Oh, it looks like I wrote this in the wrong place. So I figured out that little a from the previous problem, 2.95 in yards. And then for the last angle here. So if I have two of the angles, if I have angle C and I have angle A, to find the third one, I can just use the sum of 180. So 180 minus the angle that I found was 45. The angle that they did give you was angle A, and you figured out what angle C is. So now you just have to figure out what B is. So I'm going to take 180, subtract it from 45 degrees, and then subtract it by this angle that we have here. So that's negative 4.14 degrees. And so if you put this in and subtract off the angles, you get 93.6 degrees. So in this case, your one of your chairs is 93.6 degrees. And that's it. So hopefully that helps you guys out with solving triangles using laws of cosine.